All right, in this video, I'm going to go through page 1 of the Unit 5 study guide for Math 3. If you have any questions along the way, feel free to let me know. Send me a message through Canvas or pop into Zoom and we will answer some questions. The very first question is a kind of a review question from last unit. It's use synthetic division to determine the quotient of x cubed minus 8x squared minus 3x plus 10 divided by x minus 1. So first thing we're going to do is take what we're dividing by, so this factor here, x minus 1, and I want to find its 0. So x minus 1 equals 0, which means x is equal to 1. So that's going to be the number I'm going to divide by in my synthetic division. And then for the cubic polynomial here, I want to just pull the coefficients. So 1, -8, -3. Please make sure you're grabbing the signs, by the way. So 3, 2, 1, none. All right, a little bit of work here. Drop that first number straight down. I'm going to multiply. I'm going to add. I'm going to multiply. I'm going to add. I'm going to multiply. I'm going to add. So now this last number that we just found is the remainder. This next number to, next number to the left is the constant. Then we have x to the first, x squared. All right, so my quotient here, if I put it all together, is going to be x squared minus 7x minus 10 with no remainder. All right, so problem number 1 is done. There's nothing else that we need to do for that one, so we're good. Okay. Number 2 and number 3 are similar problems. Use the graph in any method to determine the factors. All right, so we need some factors down here. So first things first, I know that this is x equals -1, which means the factor would be x plus 1. And I know that this is 1, 2, 3, x equals 4, which means the factor would be x minus 4. The problem is I have a factor sitting right there, that's the green one that I just highlighted, that I don't know what that factor is. I gotta find it. So I'm going to use the two zeros that I know and some synthetic division. So the first 0 I figured out was -1, and I'm going to pull the coefficients from this polynomial. So 6, -28, 6, and 40. All right, drop that one, multiply, add. Let me make sure I did this right. 6, -28. Yep, okay. So that's going to be -34. -1 times -34 is +34. Add those together. That's going to be 40. -1 times 40 is -40, remainder of 0. Okay, so far so good. So now I'm going to use these. I'm going to highlight this. So these 3 coefficients and the other 0 that I knew, which was 4. And I'm going to do another round of synthetic division. So 6 drops. That's going to be, what, 4 times 6 is 24. -34 plus 24 is -10. 4 times -10 is going to be -40 with a remainder of 0. So remainder, constant, x to the first. So my other factor here is going to be 6x minus 10. So there's all 3 of my factors. Now I'm going to do the exact same kind of process for problem number 3. Okay, so let's see, which ones do I know? I know this is x is equal to -3. So that means my factor would be x plus 3. I do not know that factor right there, or that 0. It's I could take a guess, but I'm not going to. And then this factor is x equals 1. No, that 0 is x equals 1, which makes the factor x minus 1. So I need another factor. Let's start with the first one I found, which was -3. That's my first 0. I'm going to grab my coefficients here, -12, -38, +8, and then 42. All right, first one drops. So negative 12, that's going to be 36. That looks like it would be a negative 2, so that's going to be 6. I believe that's 14. Let me double check. Negative 3 times 14. Let's see, it should be negative 42. All right, so that remainder is 0. So now I'm going to focus on just these coefficients. I'm not going to worry about the remainder. And I am going to use my other x0. So x is equal to 1. So 1, not negative 1. Try again. All right, 1 goes there. Little space to work. Drop that first one straight down. So that's going to be negative 12. That's negative 14. That's going to be negative 14, which is a remainder of 0. So remainder constant x to the first. So negative 12x minus 14 is my other factor. There we go. All right, so those are kind of the review questions from last unit. Let's pop into 4 and 5 here. So directions, state the domain restrictions, then solve each rational equation. All right, so I'm going to zoom in on problem number 4. I want to, for domain restrictions, just look at my two denominators. Okay, so off to the side here, I'm going to set each one of the factors equal to 0. So p minus 2, p plus 2, these are both equal to 0. So let's see what we get here. So p equals 2, p equals negative 2. That's one denominator. Separately, I can figure out my other denominator, set it equal to 0. So each factor gets set equal to 0. So p equals 3, p equals 2. All right, so my domain restrictions here, p cannot equal 2, negative 2, or 3. So those are my domain restrictions. The next thing I want to figure out is my LCD. And the nice part is this particular problem is already factored, so I just need to focus on the factors. My first fraction has factors of p minus 2 and p plus 2. My second fraction here has an extra factor here of p minus 3. But this factor of p minus 2 has already been listed. So this one's fine. My LCD is now written. So I'm going to take that entire thing. So let's see. I'm going to take this times p minus 2, p plus 2, p minus 3. Same thing for the second fraction. And really, you would use this LCD across any terms in your problem. So in the first fraction, p minus 2 and p minus 2 divide out, p plus 2 and p plus 2 divide out, leaving p minus 3 from the LCD and the numerator of p minus 3. This is going to equal, now I'm going to do the same thing. So p minus 3 will divide out p minus 3, p minus 2, p minus 2, leaving p plus 2, p plus 2. Now, I do have a quadratic equation to solve, but I no longer have any fractions in it, which is a nice thing. So I'm going to distribute on the left side here. So p squared minus 3p minus 3p minus, nope, plus 9 equals, I'm going to distribute on the right side. P squared plus 2p plus 2p plus 4. Let me clean up some of this mess. So p squared minus 6p plus 9 equals p squared plus 4p plus 4. Now, I don't know if you recognize this, but if I were to subtract p squared from both sides, both of those terms would cancel out, which is really nice because then we really don't have a quadratic equation anymore. I'm going to collect all of my variables to one side, so I'm going to add 6p to both sides. And I'm going to collect my constants to the other side, so I'm going to subtract 4. So let's see if I can collect up this mess. 9 minus 4 makes 5. 4p plus 6p makes 10p. So I'm going to divide both sides by 10. 5 divided by 10 is 1/2 or 0.5. So P is equal to 1/2 or 0.5. Quick double check. That is not one of my domain restrictions, so that absolutely can be my answer for the variable. All right, so problem number 4 is done. Lots of work there, lots of different steps, but if you can follow along, you should be okay. All right, I'm gonna slide over to number 5, the last problem for this particular video. Again, I wanna focus on my denominators. So I have my denominator on my left, denominator on my right, and I'm going to separately set each one of those denominators equal to 0. Now I need to factor them. So let's see, plus 5 minus 3 equals 0. So x plus 5 equals 0, x minus 3 equals 0, which means x equals -5 and x equals 3. So that's one denominator. My other denominator is x squared minus 25 equals 0. I'm going to go ahead and factor that one, x minus 5 and x plus 5. So x minus 5 equals 0. Remember, set each factor equal to 0. So x equals 5, x equals negative. Whoops, that is a horrible 5. Let's try that again. X equals -5. So my total domain restrictions, if I collect them all up, x cannot equal -5, cannot equal +3, or +5. This -5 was duplicated here and here, so you only have to write it down once. All right, so there's my domain restrictions. Let's talk LCD. Now, the nice part is we've actually already factored these. I'm going to go ahead and stack the factors up. So this was x plus 5, x minus 3. This was x minus 5, x plus 5. So LCD, we've got the factors of x plus 5, which would take care of this term and this term. I've got a factor of x minus 3, which would take care of that little piece, and x minus 5, which takes care of that one. If those little dots help you to keep track of things, do it. Do what helps you when you're solving these problems. So now I'm going to take this entire LCD and multiply it times, in this case, I've got 2 pieces of the equation. So I'm going to multiply it times both pieces. So LCD x plus 5, x minus 3, x minus 5. All right. So if I zoom in on just that part, again, my LCD is done and my domain restrictions are done, so I'm not worried about that part of the problem. So x plus 5 will divide out x plus 5. X minus 3 will divide out x minus 3. So I just want to collect up what's left, which is this numerator of 3 and this x minus 5 from the LCD. So 3 times x minus 5 equals. All right, let's see what divides out on the right side. So x minus 5 takes out x minus 5. X plus 5 divides out x plus 5. So I've got 2 times x minus 3. A little equation to solve, but no more denominators, which makes it nice. So we've got 3x minus 15 if you distribute, and 2x minus 6. I'm going to collect all of my variables to one side, so subtract 2x, and I'm going to collect my constants to the other side, so add 15. So those two will subtract and add each other out. So let's see, 3x minus 2x is just x, or 1x. And then I've got -6 plus 15, which is 9, I believe. It is 9. Let me do a quick check. 9 is not one of my listed domain restrictions, so that can be my answer. So it says to list the domain restrictions. I did, and solve. I have done that. All right, at this point, I'm going to go ahead and close out this video for page 1. If you